Alright, so we're going to be talking about Chapter 1 Introduction today. And really this is just to kind of give you a basic understanding of what .NET is in general. So around the year 2000, Microsoft created .NET, and at this time the web was really just starting to take on that web boom and a lot of functionality for different applications. And there was a lot of mobile applications finally starting to come out, and not just mobile phones, but just mobile electronics with dealing maybe like the factory floors or anything that was mobile. People needed that to get their job done. And so Microsoft really recognized this boom, and they realized that they kind of had all these different languages out there that they were maintaining. And they kind of wanted their piece of the market share and wanted one sort of language to be able to kind of rule them all. And so they came out with this idea of .NET. So they kind of took a look in industry and looked at the different languages that were coming out at the time. And they also looked at the history and said, okay, let's look at all these different languages and let's try to take the best of all these languages that we can and kind of leave out the worst features. And so at that time, Java was kind of the big language that was out. If you were a Java developer, you were making a ton of money at this time, even with just a little bit of experience. And so they knew that while Java was so popular, that's where they were going to have to base a lot of what .NET was working, and that's exactly what they did. They stole lots of ideas from Java. However, at the same time, the main languages out there, and this is even almost true still to this day, are C and C++. So they knew they had all these developers out there that are using C, C++, and now Java has this huge boom. So they kind of stole the main features from these three languages, and that's where the roots of C# comes from. So you'll notice when you're doing your syntax in C# that it's going to look very, very similar to C, C++, and Java. And they did that for a reason. So think about your team at work. You're in this team, and you're starting a new project. Let's say you have 10 developers on this project, and you all know Java, for instance. And so now you have this new project that comes out, and you do a trade study on what language you should do in the future. Well, okay, you have all Java developers on your team, so that's going to be their initial idea of what to use, right? That's what they're familiar with. Well, Microsoft recognized this, so that's why they made C# look so much like Java, so that Java developers could easily transition into a language like C#. And the same is also true for C or C++. There's just a little bit of syntax difference in a few minor areas, but other than that, you almost can't even tell the difference between the languages. So if you just come from a Java class or C or C++ class, the syntax itself of C# is going to be really easy for you. And you're just going to have to then understand the .NET language and the classes and libraries and things like that on how to do it. So now they had to actually develop their interface for how you'd write the C# language. So that's where they came up with Visual Studio. So Visual Studio is the .NET IDE, and you'll hear that sometimes referred to as Rapid Application Development, or RAD. And so this is also, as a side note, the kind of thing you would see as a test question. And if you look to the lecture on the outline for the midterm or final, you'll see some key words such as RAD. And so rapid application, it's just a sort of a term that you just kind of need to understand what it's really referring to. So kind of as a history language of where C# came from, there was also all these procedural languages out there like Fortran, Pascal, Basic, and C. And so they actually wanted to kind of get away from these type of languages, because what we found is that they're kind of a little bit more error prone and harder to maintain. And again, it took years to realize this, and they're not bad languages. It's just languages progress, and we add more and more features to them, and they become more and more complex, and projects become complex, and they become larger and larger and almost impossible to maintain at times, just because the nature of these languages. So that's why object-oriented languages have sort of taken off in the last 20 years or so. And the reason for that is just how you can group your code together into something called objects. And when you create an object from a class, and these keywords we're going to go over these a million times during the lecture, so if they don't make perfect sense now, they will in the future. And so all of these languages are called object-oriented languages. And that really just means how you structure and organize your code. That's all it's about. You just try to create classes, and when you create and an instance of those classes that are called objects. So for instance, let's say we're creating some sort of application for a business, and this is going to keep track of our payroll system. And so what we would do is you would then come up with all the different classes that represent real-world objects. So for instance, you may have some employee data that we're going to have to save to a database somewhere. So what we do is we create a class that represents an employee. So inside this class we'd have attributes, variables that first name, last name, address, social security number, maybe their salary, things like that. So once we have a class, then what we can do is we can actually create an instance of this class, which is an object. So we'll learn a bit more about this later, where I like to think of the idea like a blueprint of a house. So what that really means is that we have this blueprint, right? It's just a piece of paper, and it's just the drawings for what will make up a house, right? You can't live in this blueprint. You can't use the blueprint for anything other than putting the work in to create real houses. But from that one blueprint, you can create as many houses as you want, and then you can customize those houses. Well, that's exactly the same with class as an object. So your class is your blueprint, and so for instance we have this employee or person class, and it holds all of their information that describe an employee. But this class you can't do anything with. It just simply describes what an employee is. Again, the first name, last name, address, things like that. But from this one class, this template or blueprint, we can create as many objects of that class as we want. And so once we instantiate an object, then we can start filling in the first name, last name, address for this employee. Then we can instantiate another object of this class and fill in this different employee's information. So we can create as many objects as we want. And we can do that, and that's what's called object-oriented programming. Where in the past we had these procedural languages. So a big reason that I talk about something like this with procedural languages is not necessarily understand where C# came from, but more than likely you have to remember your career is going to span 30 or 40 years in computer science. And the idea that you're going to end up in one company and working on one project, maintaining code or writing new code in one language for the rest of your career is about zero, is about the odds of that. So that's why I kind of talk about these procedural languages. So I've had to maintain lots of programs written in Fortran or I've also had to do Ada, for instance, because I deal with the Air Force a lot. There's a lot of history of the Air Force using Ada for their programming languages. So it was just a fact. I had to, just pick up some Ada skills and had to maintain some old Ada code. So that's where you understand where these procedural languages, they're just top down, which means it literally just starts executing at the top and it just line after line in a sequential order. Now they do have things like methods that they can pop out, but however, kind of the way that they can mimic sort of an object-oriented type and get functionality and get more functionality into their programs is with the use of go-to statements. And so this just literally allows the code to go wherever it wants in the code. Now, one of the things I've noticed as I was maintaining these old languages, or I've also done projects where I've had these massive projects that were written maybe in the 60s or 70s in Fortran, and now we're taking that same project and we're converting it to a new project now. And so we picked C#, for instance. So we had 100,000 lines of code that were written in Fortran. We're converting all of that to C#. And so what I noticed is that, okay, so not only do I have to get my head wrapped around how to read Fortran and understand it, but one of the things, the big lessons that I learned, this real world knowledge that I gained, was that it is so important to write properly well-structured code, to comment your code, and just overall make it maintainable. Because it's one thing just to get the job done and make sure it works. It's another to always have in the back of your mind this other developer 10, 20 years from now that has to maintain your code. And so what I found is that, let's say I'm working on this one particular chunk of code, and back in the day with this particular project, what they always used to do is they would have the developer's information at the top of every file. And so I would know when I brought up a file, I would read certain people's names at the top of this file, and I knew who wrote this code, and I learned really quickly who were the good software engineers and who were the bad software engineers. Never met these people in my life, but I just recognized in their code just how well they could write structured code, how well their comments were, how well they created variable names. You know, some people would literally create variable names like ABC or XYZ or AAA, and that would hold some name or some value from a calculation or a loop variable. And that's literally how descriptive their variables were. So the only way I could ever figure out what these variables even mean is I'd have to go to the top of the code and find where they're defined and then fall through the code to figure out what in the world they were even being used for. Where other developers who really understood software engineering and not only were trying to get the job done, they had tasks in front of them at the time, but they could think about developers 10, 20 years in front of them, and they also knew that if they had to maintain this code 5 years from now, that the more well-structured they created this code, the easier their life is going to be in 5 years, because you will not remember your own code and how you structured it and how this program worked, because you'll be writing some pretty complex programs in the future. So do yourself a favor throughout this class, really take the time to understand what well-structured code means and how you write it and how you abstract out your code, because it really does make a difference for future programmers. So some other terms we're going to kind of learn about in this class. We'll be dealing with XML a little bit, and this generally deals with internet a little bit more, but there's some objects in .NET that store information with XML, especially when we get into databases. So we'll be talking about XML a little bit later. So .NET, what really is .NET? What did Microsoft create with their idea? So the first thing that they came up with, which is kind of a brilliant idea, is that we want .NET to be the overarching technology. However, we've kind of learned our lesson that languages change and people like different languages for different reasons. Even just the way syntax is written. Some people just work differently and they like the way certain languages look and feel and how you write them and how you write methods and how sometimes they want things to be very forgiving. Other people like languages that are really, really structured and there's no forgiveness as far as maybe casting goes or what the language will do for you automatically. So what they did in .NET is they actually didn't make you tie you into a specific language. So with .NET, you can use C# to write your programs, or you can write Visual Basic.NET, or you can actually use Fortran.NET, COBOL.NET, C++.NET, and there's things even called F#. And so there's all these languages that are underlying layer of what you call .NET. And so what actually happens is you write this language in either Visual Basic or C#. Those are the two main languages. C# is sort of the flagship language of .NET, and so I would generally recommend, when people ask me which language they should learn in .NET, I would say C#. Microsoft does seem to favor C# a little bit more than they do Visual Basic.NET, but there are a lot of developers out there that like Visual Basic.NET, and I'm pretty fluent in both of them, and it's really easy to jump back and forth between these different languages because all of the libraries, all the classes that you use are exactly the same. It's just how the syntax of how you use these classes. So for instance, there is something called a file class in .NET. So Microsoft has already written this code for you, how you access the file system on your computer. And you can say something like file.create to create a new file. Well, that is exactly the same in C# as it is in VB. Now there might be a little bit of different syntax, but it's still the file class. You instantiate a new file class object, and then you can use all the methods, and these methods are exactly the same whether it's C# or Visual Basic.NET, so it's kind of nice. And it's really easy to learn one language if you already know the other. The other idea they wanted was platform independent, and this was kind of the idea they stole from Java. And so Java is really well known for being able to work on multiple operating systems all at the same time. And they're able to do that is because it doesn't actually, when you write these programs, they actually don't get compiled down all the way into a machine language when you compile them. There's this intermediate step. So if you've taken a Java class, you would have heard of bytecode. And so what Java does is it uses this compiler and it compiles it down into bytecode, and then you distribute that bytecode to other computers, and then that bytecode is then compiled down to the machine language depending on which computer it's installed on at that time. So that's where it actually gets compiled and used on. And so which means that Java has to be installed on that computer and all of its libraries before you could run the Java application. Well, that is exactly the same for .NET. So in order for .NET to work, you have to have the .NET framework installed. And so that's how it becomes platform independent, because in Microsoft, when you run or when you compile a program, it compiles it down into something called intermediate language, which is just like the bytecode. Then you distribute that bytecode. Your exe is actually the bytecode, and then when someone runs it, it actually just in time compiles it on that machine, and it runs your application. Another technology they came out with is something called ASP.NET, or Active Server Pages.NET. What this is the web technology that they're using to allow you to write web pages using C# or Visual Basic.NET. And so this is a whole other paradigm, and there's actually a class here at Weber State that they offer with ASP.NET. So if you like C#, I highly recommend you take that class. One of the last lectures in this course, we're actually just going to take 20 minutes and go over ASP.NET, and we'll write a little quick web page, and we'll show you how easy it is to take your knowledge you learned from this class. If you can just get your head wrapped around how the internet works and that paradigm shift from a Windows application to a web application, all the code, C# and the classes are exactly the same. It's the same syntax, and now you can become a web developer. Another thing we'll learn about later on, again that last lecture, is something called web services. And so this is just another distributed technology that they built into .NET. So for instance, let's say we're Delta and we want to do a business venture with someone like Thrifty Car Rental, or Hertz Car Rental. And so when someone rents a car from us, we also want them to be able to, so when someone books an airline flight with us, we also want them to be able to book a rental car, because maybe we'll get residual fees from this. And so we make this partnership. Well, what we can do then is we say, hey, Hertz, how are we actually going to rent this car? Well, they can create web services for us. So on our web application, or whatever application, we can send requests to their servers, and they can control what information they send to us. And we can do that distributed technology through something called web services. And we'll learn more about those in later lectures. So just some key words. Again, these are the type of things that you'll need to know for the midterm and final. And not only that, these type of terms, again, are so you can have conversations with other engineers about .NET and understand what you're really talking about. So the first one is this idea of framework class library. And so framework class library is how .NET manages and executes applications. So this contains these class libraries. So it's all this code that Microsoft has already written for you, like this file class that we already talked about. And so this is one of the reasons you pay all this money to, your company would pay all this money to get Visual Studio, because you're really paying for this integrated development environment, this rapid application development environment called Visual Studio to create your application. And you're paying for all of this code in the framework class library that Microsoft has already written for you. That way you don't have to invent what it is for a button or a label or a checkbox or the file class or to connect to a database. So they've written all this complex code for you already. The next idea is something called the Common Language Specification, which contains information about the storage of data, types, objects, etc. So the reason that you can have multiple languages within .NET is because of this specification. So if a language is coherent to the Common Language Specification and it meets everything in the specification, then it can become a .NET language. And the reason for this is because if all your integers and your strings and your doubles, if they're all the same data types and they have the same data storage and everything, your language meets this specification, then it can be compiled down properly into an intermediate language. And so something like C# and VB.NET meet this specification. They can be compiled down properly. So you could literally write your own language in .NET. And that's how come we have things like Fortran.NET or COBOL.NET or F# as other languages in .NET. Even though Microsoft originally came out with VB.NET and C#. So one of the more important things you need to understand is the Common Language Runtime, or the CLR. And this is what actually executes your C# program. And this is extremely important to understand. So when you have this exe, let's say, first we're going to create a tic-tac-toe program during the semester. So you'll have this little executable called tic-tac-toe.exe. And let's say you double-click that because you want to play tic-tac-toe with one of your kids or friend. And so when you double-click this exe, remember, it's just intermediate language at this stage. And so the Common Language Runtime is what actually executes this particular program. And so it takes your bytecode, figures out what operating system you are, figures out the .NET languages it's written in and all that stuff, and actually compiles it down into the machine language, executes your program. Now, so what's happened over the years now is Microsoft has come out with different versions of this CLR. So sometimes you'll also hear things like, which .NET framework do you have installed? So when Microsoft first came out with the .NET framework, it was .NET Framework 1.0. So that's that whole framework class library, or all these classes that they came out with. And so the .NET framework contains everything. So all these specifications, the Common Language Runtime, the framework class library. And so if you had the .NET Framework 1.0, it had a particular version of the Common Language Runtime that executes your program. So at that time, Microsoft would then push out the .NET Framework 1.0 to all of its Microsoft Windows machines. And so that way you could, what's kind of nice is that since most computers are Windows based, generally speaking, for like home users or office users, that your program would just sort of automatically already run on Windows machines. And then as time went on, a huge update came out and they pushed .NET Framework 2.0. And this was a huge release, and they made all kinds of updates, and they learned a lot of things with this Common Language Runtime, because this compiler is extremely important for speed and memory usage. And so they learned a lot from how people are using this program. They figured out how to speed it up and make it more memory efficient with allocating and deallocating memory. And that's all done with this Common Language Runtime. And then the .NET 3.0 came out, and then the 4.0 and 4.5, and eventually we're around 5.6 probably right now when you're listening to this. So again, you're just going to constantly hear these new .NET frameworks come out, and most of the time Microsoft automatically pushes it during Windows updates to different machines. However, during an installation, let's say you create this program, you want to distribute it, you can, in your installation, you can check to make sure that a particular version of the .NET framework is already installed on a machine, and if it's not, you can then go ahead and install it on that machine so that you're guaranteed that your code will run. And if a .NET framework isn't on the machine and you try to run an executable, the program will just pop up with an error message and crash, and you won't be able to run it. So again, kind of to just sum it all up, Microsoft came up with this idea. Again, it was around the year 2000 for this idea of .NET. It had its roots in C++, and Java. Just remember, the framework class library is what contains all of these classes and libraries in the CLR. Your code is compiled down into an intermediate language, and to write your code you can use whichever language you want, but in this class we'll be learning about C#.